Please welcome Capgemini's Executive Vice President, Global Head of Intelligent Products and Services, Jeff Hebert.
Hey everybody, good to be with you. I'm excited to launch into a talk here talking about how we actually productize these edge AI-based devices. So I'm going to talk through three things. The first is what I see as the promise of edge AI. I'm going to cover, I think, a couple of topics that have already been spoken about here, but because the rest of my talk is going to be perhaps a little bit more focused on the reality and the challenges, I wanted to make sure to at least have the optimism to start. So then I'm going to hit the reality of what we see in terms of our clients getting these products actually launched and in the market at scale. And then I want to talk through some specific examples, so some specific challenges that we see, and also our recommendations and examples from our client work. So I'll give you 4 different things in that space. So yeah, to start, the promise of edge AI. We see a bunch of really cool applications in here. This is something we worked on recently in a health tech device around kidney stone removal. We've talked about this in a few of the other talks today. So it's this hyper-convergence that we're seeing where the silicon has progressed, the hardware is developing and becoming lower and lower power. We've got connectivity, whether that's 5G, 6G, low Earth orbit satellite. Connectivity has been progressing as well. And then, of course, the models are the thing that has really progressed significantly and are the main headline. So all of this together, this hyperconvergence is unlocking a really exciting new opportunity in this space, and it's kind of this inflection point. Part of the other thing that's happening here is we have this massive amount of data, even more and more data being generated by all these devices. And the interesting part here, some of this data and the research shows that really a very small amount of the data being generated by all these IoT devices is actually being processed today. So while we are seeing this convergence and this opportunity, it's still not really tapped into fully. And so we're at this transformative moment where we can actually tap into that and do more with it. So this is what's exciting to me, is moving the compute closer to the point of capture. That's what edge AI is all about. And we talked about a few of the different reasons for it. It's that time sensitivity. It's access to first-party data. You're there living with the customer, the consumer, the equipment, whatever that is. You're actually gaining access to it directly. And you can actually change the physical world, too. That's the part that I find super exciting about this. It's not just about sensors in one way. It's about two-way interaction and robotics and actuation and automation and actually changing and bringing value to the physical world. So that's what I find exciting. And when I think about this, I think about it kind of like a flywheel that we can enable for our clients, where we're capturing data, we're bringing the end customer value in exchange for their data, and then we're pairing that data with things like our in-house insight. So this is from our example, and I'll talk about this in more detail in a second with Nestlé Purina, where it's not just about the sensor data that we're gathering from the edge, it's also about pairing that with their own in-house knowledge. All the veterinary insights, all the things that they would normally build into developing your cat food and your litter and everything that you buy as a consumer, now they can bring that to you, that insight, and expose it to you through AI, not giving away their trade secrets and their confidential information, but pairing that together and providing really valuable insight to you as a consumer. That feeding back to you with these services, that's the overall ecosystem that I think is really exciting about the way that these edge devices can help bring value to consumers in this market. So that's all the exciting stuff. The rest of my talk is about the reality and the challenges that we see. Because our business, I'm the president of Synapse product development, and I'm EVP within Capgemini, focused on intelligent products and services. Our whole business is helping our clients get to market. Not just a POC, not just a pilot, but getting to market with a successful product and service where they can make money out there and provide value for customers. So we see a lot of reality here of actually getting through those stages. We've run a large survey recently through our Capgemini Research Institute, where we were asking companies about their experiences in this space. And what we saw is that many, many, many companies are excited about the promise of intelligent products and services. It's 88% of this large number of companies that we surveyed. But at the time, only 7% of them had actually scaled up the use cases for these, and 50% of them were stuck at these pilot and POC stages. Now, as an engineer, I like to think that the reason for this is because it's hard. Like, The engineering to actually do this is difficult. Making the algorithms is difficult. Porting them onto a device is difficult. Battery life, form factor, all these things are challenging. And that's certainly a part of it, and that's most of what I'll talk about here because I'm coming from the engineering side of the equation. But there's certainly some other pieces too. There's monetization. There's user experience. Is it actually, worthy of getting out there into the market? And there's ROI. Like, how hard is this to develop versus how much money are we actually going to make with it? And if we pilot it and we POC it and it's not making sense, well, probably shouldn't make sense to keep investing into it. So there's a bunch of reasons behind this number of 50% getting stuck at these stages. And so what I wanted to do for the rest of the talk is really dive into some of those specific challenges we've seen clients multiple times kind of stumble over in this process. And I don't want to just be a negative person here. I don't want to just talk about the problems. I also want to give you the examples of how we dealt with it and the recommendation we have about how you might be able to navigate these things yourselves. So, navigating to launch at scale. Like I said, it's all about actually getting these things into the market. So reality number one, we talked about this before, Zach mentioned it. Lack of available training data. Almost inherently, if we're building a brand new edge device, the data that we need to fuel those algorithms isn't already readily available. We're creating that thing partly as the sensor to generate its own data. And so we've got this challenge to overcome. And part of what we've seen clients struggle with in this space is that actually the effort to capture that data and tag it and have good ground truth can be even more effortful than developing the models and developing some of the hardware itself. This is the sort of dirty secret of AI-based products. So a specific example, and this is going to tie together with a talk in a minute here, and we've already mentioned this product, so I don't need to explain it in gory detail, and that's a good thing, is because we helped Nestle Purina with this smart litter box. And the key thing to understand here is that this is a sensor that was living in a consumer's home. The simplest way to understand what would be happening in this scene would be to use a video, to use a camera. But we're talking about entering into a consumer's home, likely into their bathroom. Putting a camera in a bathroom is not okay. And so we had to develop a sensor that wasn't unobtrusive from that perspective. So all we're getting is load cell data. With load cell data of a cat climbing into a litter box and doing their business, we can't necessarily know what the ground truth is. So the sensor itself doesn't give us the actual ground truth, and therefore we need to create some way to understand and to tag and to associate and to develop the model. And in this case, we knew that we needed to tackle some pretty sophisticated challenges, even if we're talking about bathroom behavior, which is if you have multiple cats in your household, how do you distinguish between them just with load cell data, some of these other challenges. We knew that it would be a pretty sophisticated model. So in this case, for those reasons, we ended up creating an entire engine that enabled us to collect that data. We used a camera in the development environment while we were capturing that load cell data, and then we were able to create this engine that associated the two and provided kind of automatic tagging for us. And that allowed us to collect 300,000 data points that then fed into the algorithm and was able to tell the nuances of all these different aspects to be able to provide insights about pet health. So this was a simple example of a way that we've helped attack this problem, and I think the main recommendation I would have is if you run into this challenge where your training data doesn't exist, and especially if the data that you're able to capture from your sensor doesn't automatically tell you what the ground truth is, and also, if you need a lot of data, if you're going to end up having a very significant algorithm here, that's a good kind of trigger, those three things together, a trigger for you to say, actually, I should build an engine because I'm going to need it both for my initial product development, but also for future development of iterations of that product. Now, we've heard about synthetic data, so I want to make sure I'm not overly focused on this side of custom data collection. Synthetic data is great, but of course, there's going to be these challenges where you might end up with overfitting, or you're not able to necessarily cover all of the different edge cases that you end up running into in the real world. So it's certainly something to pair or to merge together, but for an application like this, it made sense to go and create that custom engine for data collection. Okay, that's 1 out of 4. Here we go. Number 2, concurrent hardware and AI development. We've run into this a bunch. You basically hit a catch-22 when you're doing your product architecture and specification. how accurate and what kind of fidelity do we need from the sensor, and what kind of AI model should we use? How do we answer each question without the other? You're kind of stuck. You sort of need to break the stalemate somehow. So an example of how we've addressed this in a specific application, this was for machine vision, and it was being used at crowd scale. So we're looking across a crowd of people walking through in a venue, kind of like this, and being able to pick out faces, and then feeding those individual faces up to an AI doing facial recognition in the cloud. So it needed to be able to work really, really quickly at the edge to pick out those images of faces. And in order to kind of break that stalemate, because we were going to create a custom device that went into venues that had a camera and the edge processing, to break that stalemate, what we ended up doing was actually using just off-the-shelf video stock footage of crowds walking around to start, to get a feel, and to understand if we could turn down the frame rate, if we could turn down the resolution, and get to a point where we could understand what threshold might actually be the kind of bottom end of still acceptable to drive an AI for the facial recognition, then we knew, okay, this is where we can set the specification for the hardware. So this was a bit of a hack, and I share this simply as a way for folks to think about and kind of break through that stalemate with products that you're developing out there, to kind of create that sensor with headroom, go off the shelf to start, and then detune and figure out where your thresholds are. So that's really the recommendation in this case, is to take that approach. The other thing that I'd call out, and this example with facial recognition was a good one, is you've got two different axes on which you're innovating. And if at all possible, innovate on one axis. If you have an existing algorithm that you know will work pretty well to pick out faces from a crowd, that helps you say, okay, that part I'm not innovating, the TRL is super high, let me focus on my other axis. How sophisticated can I make this sensor? So that's, I think, another way to kind of break through this challenge and get through the stalemate towards new product development. The third one that we see quite a bit is that people will get off to the races using modules, using platforms, using off-the-shelf technology as much as possible, and that makes really good sense, and you absolutely should if you can. But then after developing that and getting to a POC using those types of modules and platforms, you hit this wall because you realize, as we talked about a few minutes ago, the form factor needs to be miniaturized, the battery life is not as long as it needed to be, the latency is too high, the cost is too high to be able to scale up. And so then it's a bit of a back to the drawing board. And now I've got to re-architect a custom hardware product from scratch. So this one in particular is painful because you might have been thinking you can go on this path, and then you realize, uh-oh, my funding isn't going to pan out. I'm going to kind of hit the valley of death here, and we're not going to get actually to the realization of this product. And so in this case, the example is from work that we did with Levi's and Google. And we were developing the technology where you have touch-sensitive fabric. And the idea with this, the initial embodiment was into a jacket, but you could imagine it going into your couch or any other location where you're basically using your fabric like your touch screen on your phone. And in this case, we were working on taking the translation of those signals into how do you command your phone from that fabric. And this needed to fit on a jacket. It needed to fit on a person in a wearable form factor. So we knew from an architectural perspective that it had to be a really tiny form factor. So using a module for this, using something more off the shelf just wasn't realistic. And the way that we kind of hacked that in between was to then create a non-form factor board, which hopefully all the developers out there know well. But putting that tiny MCU on a non-form factor board and having us be able to collect data signals and actually develop the AI algorithms for this product in a non-form factor environment as much as possible, kind of mirroring that module approach, was able to accelerate the development and get us to a point where we could actually prove out that this low-power AI classifier could be used for gesture recognition. Okay, so that really the kind of takeaway on this one is It's kind of product development 101, but it's hard to do this right and to do it really well, which is to start at that beginning of the product development lifecycle with your understanding of these constraints at the beginning. What kind of form factor are you really working with? What kind of battery life do you really need? What kind of latency? What kind of cost? And if you can set those at the beginning, then you're going to know kind of when the road diverges in the wood, if you can do this fully custom approach, which is going to be way more expensive and take more time, but maybe necessary, or if you can take this more module and off-the-shelf based approach. The other one that I think has come up a number of times in this vein here is that you might be able to develop that product generation 1 with this specific algorithm, optimize everything and pack it in. If you do that all line to line and you use up every last bit of memory in that product, future iterations of your model, any future feature development, everything else, you are in a bad place. And we've seen a number of challenges in this in projects. So I know this is a little bit easy to say and hard to do, but plan in some headroom from a memory and a processing perspective, future-proofing yourself for future iterations of that product. So it's really kind of back to product development basics, but easy to skip, easy to misplan for. Okay, the last one. The production environment nuances are wildly different and cause major issues compared to the development side of things. Hopefully everybody knows the NASA TRL scale. I love this thing. It really helps to differentiate between where you are in the maturity of development of a product. And one of the biggest things that it calls out is there's a huge difference between getting something to work in the lab, a representative environment, and a production environment. And so really this I think just applies again to these edge AI devices. So a specific example that we worked on that was a machine vision device. We were able to set all of these specs. We tried to do it right, just like I described, product development 101. What kind of lighting, what kind of frame rate, what kind of resolution, what's the environment, all these details. We tried to do it all right at the beginning, but it wasn't until we actually got into the final production environment that we learned a bunch of our pretty good and well-founded expectations didn't pan out in reality. The challenge was lighting especially was completely different than what we were expecting. And so now you're trying to do object detection with backlighting, and it's failing. Your model's failing, and you're unable to solve for it. So this really resulted in a big spin backwards. And the main takeaway here, it's the pretty simple one, but again, easy to miss, is capturing that real-world data. This is a little bit of that cautionary tale right now about the synthetic side of things. I think synthetic is great, but pair it with real-world data. Make sure you're covering those nuances so that you don't get stuck at the late stages of your development and have a dead end like this. Bake those real-world tests and as early as you possibly can into your development. So that's really the things that I wanted to walk through with you all. I realize these are very focused on the how and the challenges of actually getting these things and these types of edge AI devices to be successful in launch. And that's really the focus of where we've seen clients fall down perhaps the most. So yeah, to summarize, if you don't have good data, you don't have a good way of tagging and collecting that data, and you need a lot of data, build a data collection engine. Start off the shelf and figure out where your thresholds can be by detuning that sensor data to begin with, if you can. Define your critical requirements up front, give yourself some headroom, and then finally, I think, do not delay real-world testing. Make sure you get it out there and you test it in real production environments with real people. They will do things you never expected. Okay, that's my talk. Thank you all.